Somebody wants to say hi before the video starts. Say hi, Connor. He got to my glue stick. Okay. In this video, we are going to be doing what are you doing, huh? You want to be heard over there? Alright, in this video we're going to be doing the Got It for lesson 10.2, which is about similar figures. Okay, so the Got It number 2 says JKLM. Hey, Connor. All right, that's enough. JKLM and PQRS are squares. Given JKLM is similar to PQRS, describe a sequence of rigid motion followed by a dilation with center 0, 0 that maps square JKLM to square PQRS. Okay. So what we need to do is, well, we have to figure out how did we get from JKLM to PQRS. All right, and first we have to figure out, well, which points map to which points in the figures. And we see that J is the first letter and P is the first letter in both of our figures. So J maps to P, K is the second letter, and Q is the second letter. So K maps to Q, right? Where's K? K maps to Q. L maps to R. And then M is the last letter and S is the last letter, so M maps to S. Okay, so that's the first thing we had to figure out. Okay. So let's see the order here. We have JKLM and PQRS. All right. Well, we notice that the order is switched up a little bit here, the order of the corresponding sides, because we have J and P. Oh, look, but J is in the top, the upper left-hand corner in our first figure, but P is in the lower left-hand corner. K is in the lower left-hand corner, but Q is in the upper left-hand corner in our second figure. So there's definitely a reflection involved here because the order of the letters have been rearranged. So the first thing that actually happens here is we take this figure, JKLM, and we reflect it across the line of reflection, which is right here. That is the line of reflection, and that is a line that goes through the y-axis. Okay, it's going through the y-axis at the point 1. So first there's a reflection across the line y equals 1. Okay, so this is the line y equals 1, right? Because again, the line's going through the y-axis at the point 1. So let's see where JKLM would be. And notice at the end, right? By the end there will be a dilation because these figures are different sizes. The second figure is bigger, which means this is going to be an enlargement. So these are similar figures; they're not congruent figures. All right, so we have J is 1, 2, 3 away from the line of reflection, which means it needs to be 1, 2, 3 on the other side. So here's J prime. K is 1 away from the line of reflection. So it has to be 1 away over here. So here's K prime. L is 1 away from the line of reflection, which means it needs to be 1 away on the other side. Here's L prime. And then M is 1, 2, 3 away, so it needs to be 1, 2, 3 on the other side of the line of reflection. There's M prime. Okay. All right, so here is our figure. Okay, J prime, K prime, L prime, M prime. And now let's make sure that the orientation of the letters and the order of the letters and the arrangement are in the same order. So we have J in our figure right now, after we reflected the original figure over the line y equals 1. Now we have that J is in the lower left-hand corner, and J corresponds with P. P is in the lower left-hand corner. K corresponds with Q, and both Q and R are in the upper left-hand corner of the figures. L and R, right? R and L are in the upper right-hand corner of our figures, and then we have M maps to S. S and M are in the lower right-hand corner of our figures. So now we have the orientation is the same way. So now we just have to figure out what was the dilation that happened. Okay, there was definitely a dilation, right, because the figure got smaller. So we have to figure out the scale factor, okay, which we know is an image side length over an original side length. Okay. So let's see. Well, again, we want to get corresponding sides. So we could do JK, which is the first two letters, corresponds with side PQ. So let's see. We have JK is right here, and PQ, right? They're both in on the left side of the figures. So the image side length would be PQ, because that's where we want to map the whole figure to end up mapping to the image. So PQ over JK. Okay, those sides correspond. So let's see, the side length of PQ is 1, 2, 3, 4, 5, 6. And then the side length of JK is 1, 2. So the scale, the ratio between the side lengths of the figures is 6 over 2. Well, 6 over 2 is like 6 divided by 2, which is 3. So the scale factor is 3 here. If we were to check other sides, right, if we were to check KL and QR, right, KL and QR, it'd be the same scale factor. This is a square, right? If they're both squares, the scale factor is going to be the same. And since these figures are similar, they told us that they're similar, the scale factor is always going to be the same. Which means that this figure right here, PQRS, is 3 times bigger, right? Because our scale factor is 3. It's 3 times bigger than our original JKLM. All right, so what you want is to say, if you give this sequence of rigid motion, you're going to say a sequence of a reflection across the line y equals 1, followed by a dilation with center 0, 0, and a scale factor 3 maps JKLM to PQRS. Okay, so that's what we just described, how we mapped JKLM to PQRS. All right, make sure you have these notes, and then you can move on to the classwork for today.